Hi everybody and welcome back to our video for review topic number 5 of Unit 3 in Math 1, which is about when we have a function versus not a function. So now that we've learned about graphs and lots of different ways to describe graphs, we need to talk about when graphs are functions versus when graphs are not functions. And so we're going to talk right now about what makes a relationship a function versus not a function. A function is a special type of relationship where every input has exactly one output. One of the things we sometimes think in our head to help us remember this is that every person can only go to one party. And if it helps you to think about this like that, absolutely that's what you should do in your mind while you're doing these problems. So let's start by looking at tables. If I'm looking at these tables, I can see that -2 is going to 3, -1 is going to 3, 0 is going to 2, and 1 is going to 5. So each of the inputs in the x column is only being assigned to one output. That means that this is a function because, so I like to write b/c instead of because, every input has exactly one output. Now, if you look at the second table here, it looks to me like the -2 is being assigned to two different outputs. It's being assigned to the +3 and the +4. It is not allowed to do that. In the function world, every input can only have one output. So I would say that this is not a function because, and I like to write b/c, because -2 has more than one output. And that's not allowed. That's illegal in the function world. Now, what if we're given a different representation of a function? So what if we're given a mapping diagram where we see the relationship between the inputs and outputs in a different way? Well, we can still use the same thinking in order to figure this out. So if I look at the inputs here in this first bubble, each of these inputs only is going to one output. It's got one arrow going to one output. So I would say that this is a function because every input has exactly one output. If you look at the second example here, you can see that the number 5 is trying to go to two different outputs, the 4 and the 7. So I would say that this is not a function because 5 has more than one output, which is not allowed. Next, let's look at these lists. So again, this is just a different way of looking at a function. So in this first list, 2 is going to 4, 3 is going to 4, and 4 is going to 6. Now, each of those inputs, the 2 and the 3 and the 4, are only going to one output. So I would say that this is a function because each input has exactly one output. Now, if you look at the second example here, we can see that the number 2 is trying to go to two different outputs. It's trying to go to 4 and 5, which is not allowed. So I would say that this is not a function because 2 has more than one output. Now, the only time that we can't just think about it as inputs and outputs is when we have a graph. And the reason that that doesn't really work for a graph is that a graph doesn't really just show us a list. We have to think about it from a visual perspective. When there's a graph, we have to think about what's called the vertical line test. And what this test says is I can test whether this is a function or not by drawing vertical lines. If I draw a vertical line and it only touches the graph in one spot, that would be a function. If I draw a vertical line and it touches the graph in more than one spot, that is not a function. You can think about the vertical lines here as being like the inputs and how many times they touch as being like how many outputs there are. So in this case, we would say that this first one is a function because it passes the vertical line test. And we would say that this second example is not a function because it fails the vertical line test. All right, that is it for whether we have a function or not. Thank you guys so much for watching, and next you'll be doing some practice with this idea.